I wanted to work out a problem that involves projectile motion. In this particular problem, I'm standing atop the chemistry physics building. I throw a house brick off the roof into the parking lot below, and I throw that house brick at 15 meters per second. I throw it at an angle 30 degrees above the horizontal. It takes 3 seconds to hit the ground. And based on that information, we're asked to figure out the height of the chemistry physics building. And so that's my goal. And so this is an example of projectile motion. If I was to go about solving this problem, I'd start by drawing a sketch of the situation. I've actually already drawn it over here on the left. So on the left of the sketch is the building. On the right is the car park below. This curve is the parabola of the thrown house brick as it travels from the roof of the chemistry physics building to the car park below. And marked on here is the angle at which it's thrown. I call that theta, the initial velocity which is thrown, v naught. I'm just going to annotate this diagram with a little bit more information. The speed here is 15 meters per second. This angle here is 30 degrees. And the time taken is 3.0 seconds. So that's the information that's given to us in the problem. Now, when we solve projectile motion problems, we almost always resolve the projectile motion into either horizontal or vertical, or both the horizontal and vertical components, and solve the problem that way. And this problem is solved like that. Specifically, I'm going to now just focus on the vertical motion. And just to show you how much I'm focusing on the vertical motion, I'm going to draw just the vertical motion of the projectile, of the house brick. So if I focus just on the vertical motion, here's the motion. So initially it's thrown upwards, but then it falls downwards. And its initial location is on the top of the chemistry physics building, and its final location is at the base of the chemistry physics building. So let me add a few things here. Y naught is the initial height, and Y is the final height. And the difference between those is the height of the chemistry physics building, the thing that we want to know. And then V naught Y is the initial velocity in the vertical direction. Now, it's a portion, a piece, a part of the total initial velocity of the thrown brick. The piece it is V naught sine theta. Well, V naught's the magnitude of the initial velocity, and theta is the angle which I threw the house brick. So I can calculate that initial velocity in the y direction. It will be 15 meters per second times the sine of 30 degrees. You probably remember sine of 30 degrees is a half. And so this is just 7.5 meters per second. So that's the initial velocity in the vertical direction. I know that quantity. I also know the acceleration in the vertical direction. That's downwards, 9.8 meters per second squared. That's the acceleration of gravity. And then finally, I also know the elapsed time for the journey. That was 3.0 seconds for the time from the release of the projectile to the projectile striking the ground. And so this is a second picture of the motion from this vertical perspective. And what we want to figure out here is the vertical distance traveled, because that's the height of the building. And now we got the picture, we can turn to the equations of motion that in a quantified way describe the motion, and figure out, see how we can calculate the vertical distance traveled, or the height of the building, in terms of the quantities we know. So I'm led to the following equation. On the left-hand side, I got the vertical displacement. On the right-hand side, I got two terms, v naught y times the time, plus 1/2 ay times the square of the time. And then this is one of our kinematics equations. And if we look at this equation, well, we can see that in this equation, we know the time, we know the acceleration, and we know the velocity. So all the quantities on the right-hand side of this equation we know, and the quantity on the left-hand side of this equation is the quantity that we want. It's the height of the building, the vertical distance traveled. And so all I've got to do is fill in the three quantities on the right. Initial velocity in the vertical direction, 7.5 meters per second. Elapsed time, 3 seconds. Acceleration due to gravity, minus 9.8 meters per second squared. And elapsed time, 3 seconds squared. And if I plug in these numbers to my calculator, I worked this out earlier, I got minus 21.6 meters. So that's the vertical distance traveled, and 21.6 meters is the height of the building. So the answer to the question here, what's the height of the building, is 21.6 meters. So, that's an example projectile motion where at first sight it might seem a very difficult problem. We're just told we've thrown a brick off the top of a building, and we told the speed and the direction we threw it at and how long it was flying through the air. And we've got to figure out the height of the building. Now, it's probably obvious that the higher the building, the longer it takes, or the longer it takes, the higher the building must be. But it's the equations of motion, those quantitative descriptions of motion, that give us the relationship, the precise relationship between that height of the building and the elapsed time to hit the ground. And we just use those equations to solve this problem, having first understood that it's the vertical motion that's important in this case, not the horizontal motion. The vertical motion is determining the time. The horizontal motion doesn't determine the time.